Okay, here we are, moving on. Page 6. What is the perimeter of a regular octagon that fits inside a circle of radius 6? Okay, so sketch a reasonably good stop sign, and if you put a circle around that, we want to know that if this radius out to here, if that's 6, what is the perimeter? Okay, so if you enlarge that, if you divide a 360 degrees up into 8 like pizza slices, each one is going to be 45 degrees. So I can enlarge that. Really, it's just saying, if we know this is 45 degrees, and this is 6 units, and this is 6 units, what's this amount here? All right. Well, if I go right down the middle, then that's going to be 22.5 degrees. And that's still going to be 6, and this is going to be 1/2 of x, or just, I don't know, call it y or whatever. But you can use trig to solve that, and when you get that answer, you can multiply it by 2 to find one side, multiply it by 8 to find the perimeter. You could also use the law of cosines. This is a length, that's a length, and then you've got these two. Either way, you'll get that amount. I think that since I've set up with the trig ratio, that's probably the easiest way to go. That's the opposite side. So I'm going to find out what that is. So opposite side over 6. So I'm just going to take the sine of 22.5 degrees, and I'm going to multiply that by 6, and I will get that length as being 2.296. If I double that, that's one side of our octagon. So if I multiply it by 8, I get a perimeter of about 36.74. Okay, so that's going to be pretty darn close. You can compare what it would be. It's going to be close to pi r squared, 2 pi r for the diameter. So 12 times pi is going to be also very close to that as a way of checking your answer. Tell how many triangles can be made and solve for the missing sides and angles. So this is solved completely. Again, if you have a little rough draft of A, B, and C, the measure of angle B up there is 72 degrees. C right here is going to be 6.2, and B opposite here is going to be 8.5. We're looking out for the angle side, which is what this is, because we're given this angle, but we do not know what that side is. So this is not side angle side, this is angle side. So we have to mind the gap on this one. We need to know what is the length of this gap right here to see if 8.5 is going to bridge it. Alright, so that's the sine of 72 degrees. So sine of 72, then times 6.2. Oh, that is definitely going to be okay because that 8.5 is longer. Alright, so 8.5 is plenty long. In fact, it's longer than 6.5. So I know there's going to be one triangle because it's no way that it can hit twice if it's longer than 6.2. Alright, so then once I know that that works, I can use the law of sines. So I'm going to say that the sine of 72 degrees over 8.5 is equal to the sine of angle C over 6.2, and then I'm just going to solve that. So clear sine 72 divided by 8.5, then times 6.2. That gives me my sine of angle C. So I do second sine and then second answer, and that gives me the inverse sine of that, and that's 43.92. So angle C is approximately 43.92 degrees. Then I'm going to find the other side because it says missing sides and angles. So now I can set it up so that the angle A, I can do some quick addition and subtraction. So this plus 72 degrees, and then I'm going to subtract that from 180, and I get 64 degrees. 64.08 degrees. So now I can set up another law of sines ratio where I do sine of 64.08 over missing side A is equal to sine of 72 degrees over side 8.5. So again, I know all these values, and I should actually turn these both upside down. There's nothing wrong with doing that. So I'm going to actually just imagine I flipped these fractions. So I've got 8.5 divided by sine of 72, and then I'm going to multiply that times sine of 64. And I get almost exactly 8. So the length A is very close to 8.04. Alright? Those are all three sides and all three angles. Okay, that's A. So for B, sketch my triangle here. If this is A, that's 44 degrees. If this is B, then this is 14. And if this is A, then that opposite side there is 11. Again, I've got an angle right here and then a side and side. So I need to know, is this gap going to be more or less than 11? Alright, so I'm going to do sine 44 times 14, and that gives me a gap of 9.7. 11 is bigger than the gap, but less than 14, so I am going to get the dread result of two triangles. This is going to take some work, alright? We'll see, this is maybe going to use up all my time, but this is the two triangles. So it says how many triangles? Two triangles. Okay, this last one was just one triangle. I will now solve for this smaller angle, angle B. So I'll say angle B over 14, the sine of angle B over 14, I'm going too fast, is equal to the sine of angle 44 over 11. And I'm just going to solve it. So I do sine of 44 divided by 11, and then I multiply by 14, and I get what the sine of B is. So I do second sine and then second answer, and I get an angle of 62.1, I'll call it. So angle B equals 62.1 degrees. Now that I know that that's what that is up there, I can add it to 44. So I do plus 44, and then I subtract that from 180. I just get negative 73, but of course it's positive, so that is going to be angle C then right there is 73.9 degrees. Now I've got all the angles. I need to find only the missing side for this first triangle, and then that I can do by law of sines as well. So I do C over the sine of angle C, which is 73.9 degrees, is equal to, and I can choose any one, so I'll use 11 over the sine of 44. Always use your original data if possible. So 11 divided by sine of 44, and then I'm going to multiply it by sine of 73, and I get 15.2. So C is approximately equal to 15.2. Don't get hung up about, your decimals being slightly different from my decimals or whatever. As long as you're very, very close, you're good. Okay, that's only one of the two triangles. Now the other triangle is when this side swings and hits on the inside. So I'm going to draw it again. It's when we've got an angle that's more, and that means it's where this angle is obtuse, more than 90, that this angle here is going to be what our angle B is there. It's a small drawing, but you can see that this would be the isosceles triangle and these will be the same amount here. So this is angle B. That's 62.1 degrees. So what's 180 minus 62.1? That's 117.9 degrees. This is still 44 degrees. So I can add this to 44 and then subtract from 180. And I get 18.1 degrees. I've got all the angles now. So angle B is 117.9 degrees. Angle C is equal to 18.1 degrees. Angle A is still 44, but now I'm going to solve the law of sines will tell me what this missing side of length A is, or length C is rather. So again, C over the sine of 117.9 degrees is equal to 11 over the sine of 44 degrees. So last time, long problem, 11 divided by the, oh, I've been going off the screen all that time, I'm sorry. 11 divided by the sine of 44, and then multiply by sine of 117. And I get 13.99, so very close to 14. Okay? And there are both triangles. This is triangle number 2. That was triangle number 1. And I hope that's clear as mud. Alright, so find the equation of the axis of symmetry, the y-intercept, and the maximum or minimum y value. This is a quadratic. Quadratics make parabolas. So the axis of symmetry, that's going to be the equation minus b over 2a, and that's going to be x equals, because it's a vertical line, so that's equal to a minus 2, that's the b part, all over 2 times 3, so that's 2 over 6, which equals 1/3. So we've got an axis of symmetry at x equals 1/3. Then for b, the y-intercept is when x is 0. That's easy. That's y equals -5. And then c, the maximum or minimum y value. The minimum y value is going to be when the parabola opens up, which it does because 3 is positive. So it's going to be a parabola that goes something like that. And that minimum value is when x is 1/3. So I substitute that in. That's 1/9. 3 times 1/9 is 1/3. Minus 2 times 1/3, 2/3, minus 5. So that right there is negative 1/3 minus 5 is minus 5 1/3. So it actually is down here. That's your minimum value, minus 5 1/3. Okay? And I will circle that just to show that it's a minimum value. Alright, write an equation in slope-intercept form. We basically have 2 points, -2 and 6, and our other point is 5, -1. I like the finding the slope by just saying what's the change in the y values. Here I draw the arrow from left to right. It's going down 7. That's the y. The change in x's goes from -2 to 5. That's positive 7. That's what our slope value is going to be, and that's -1. Now, slope-intercept form is y equals mx plus b. So I can choose either one of these 2 points. I'll just choose this one. So -1 is my y value. That's going to be equal to my slope, -1, times my x value, plus whatever b is. And I can now work out the math to see what b is. So -1 equals -5 plus b. I add 5 to both sides, and 4 equals b. So my equation then, don't have much room, but y equals -1x, x plus 4. That's my equation. And you can always double check it. Plug in -2. -2 is 2. 2 plus 4 is 6, and it works. Alright, state the domain and range of each. The domain, which of the following will have inverse functions? That's a separate question. Just the domain of this is the allowed x values. I can plug in any x value as long as I don't get a negative number here. So the 0 is going to be the boundary. So I'm going to write negative 2x minus 3 equals 0. I'll find what my boundary is. I'm going to add 3 to both sides, so I get negative 2x equals 3. So x is equal to negative 3 over 2. That's 1.5, negative 1.5. So if x is equal to negative 1.5, that gives me positive 3, minus 3 gives me 0. If x is anything smaller than that, anything like negative 1.4, then I will be in tough shape because this is going to be bigger than this. So I need x to be more negative, larger and more negative. So I need x to be less than negative 1.5. And x can be an element of all the real numbers on the number line. So that's the critical thing, is that x must be less than negative 1.5. Try negative 2. Negative 2 times negative 2 is positive 4. Positive 4 minus 3 is 1. So I can take the square root of 1. I'm good to go. So anything that's to the left of this. So there's the domain. The range then is just going to be what comes out. I can have my f of x's can be equal to 0 or greater than or equal to 0. And f of x's are going to be members of the real numbers. All right. So will this have an inverse? Yes. Inverse, okay. Now that's because graphs of square root functions fall past the horizontal line test. My crew, F&B periods, do not have to worry about this unless you're looking at a graph. I won't ask you that. We have not covered it. Absolute value, I can plug in any x in the known universe. So d, x is an element of any real number. Anything on the number line is good. What's going to come out? What's the range? I cannot get anything that's less than 0. So that's g of x is going to be greater than or equal to 0. And no inverse, in case you're wondering, because it does not pass the vertical line or the horizontal line. Fails horizontal line test based on just a simple graph that absolute values make V shapes. This one, it's all about division by 0, so you're going to factor this, and you're going to get x minus 4 and x minus 1. They FOIL to make positive 4 and add up to make negative 5, so x then cannot be 4 and 1. X can be any real number. So that's the domain right there. The range then coming out. Wow, toss that in your calculator and look at the pretty picture, okay? I'm going to put a question mark there because I'm not going to spend the time to do that right now. But you just want to ask yourself, where does the graph show? And where might there be a gap? And what is that range going to be? That's a toughie. All right.